All right, so as was mentioned, I'm here from the Center for Open Science. We're a nonprofit technology company based in Charlottesville, Virginia. We're actually only 4 years old. We were just named Startup of the Year by the Charlottesville Business Innovation Council. And our mission is to improve the openness, integrity, and reproducibility of scientific research. And through that, what we're hoping is, so what we want to do is we want to change the culture and incentives that drive researchers' behavior by building infrastructure that supports research and also addressing the business models that dominate scholarly communication currently. Everything we do is free and open. Our goal is to contribute to the public goods infrastructure, and so as a disclosure, I don't really have much to disclose, but these are our funders, and you can actually find out more information about our specific funding at the website given here. And I also wanted to start off with a confession, which is I'm not a real food scientist either. As was mentioned, I am a qualitative researcher by training. My hope is to kind of push the Center for Open Science to develop more tools for qualitative research as well. But I disclose this in part because in my perfect world, I would customize this talk to better meet your exact needs, and so I've done what I can, but that's the recognition in the beginning. So let's start off. If you were to look at this graphic, and I don't know if you can see the little letter A and the letter B on two of the squares over there, would you say that the squares where A and B sit, are they different colors? It would appear so, correct? But if I were to show you, a different graphic, they're actually in fact the same color. So what you see, why you interpret it to be different colors, is based on what we know of the world. Your brain is doing exactly what it should be doing. It's interpreting it based on what we know, our knowledge and assumptions about how it works. So we know that there's this local contrast in the grid, there's this 3D column shape there with a right floating light source that's giving a blurred shadow, and all of this information our brain processes to say that that in fact that these should be different colors when in reality they're quite much the same. In the same way, we take these implicit biases and understandings of the world, our subjective knowledge of the world, and it applies to our research. So this slide, it's taken from 538, but it's based on research that was led by my boss, the executive director and founder of the organization, Dr. Brian Nosek. And this is a study that they did looking at how often red cards were given by soccer referees to light-skinned versus dark-skinned players, and whether or not there was a bias on the part of referees when they were distributing red cards. And so what Dr. Nosek did is he solicited volunteers, and they had 61 analysts divided into 29 research teams. They were all given exactly the same set of soccer data, and each team was invited to develop their own statistical method for analyzing this data set. There was no case of fraud here. There was no misconduct. Each team actually shared their analysis strategy with others and got feedback before continuing forward. But what you can see is that there is actually a massive, massive difference in the results that were achieved by the different research teams. So despite analyzing the same data, 20 teams concluded that the soccer referees gave more red cards to the dark-skinned players, and 9 teams found no significant relationship between skin color and red cards. So when we do data analysis, this isn't, some art that's engineered to trick our minds. This is the reality that the perspectives and experience that we bring to our data can end up significantly impacting the results that we achieve. And all of this kind of goes to speak that research is hard, but context is important. And so when we're talking about openness and transparency, it's those type of results that speak to our need to have a more clear dialogue about how people achieve the conclusions that they achieve with the data sets that they're working with. Our social system, it's a complex web of shared expectations and understandings of right behavior. And in science, it's no less true. So when we're talking about norms in science, we're talking about values that are mostly implicit, unexpressed, or that we take for granted. And so I'm going to walk us through a study that was done by Anderson et al., looking at how serious the issue can be within the field of science. So they were basing their work, they were building on the work of Merton from 1942, in which he identified 4 norms of science, which was later built on by Mitrov from 1974, and he identified counternorms. So the first norm of science is openness and open sharing, that making our process public and being transparent about what we do is a good thing. The counter norm to this would be secrecy, that I want to keep my findings secret. I want to hold them back until I can achieve some sort of reward from that, whether it's publication or some type of patent or develop some application. Before anyone else can get it, I'm going to keep all of my information secret. The next norm, universalism, that we're going to evaluate our research on its own merit, that the quality of my work will speak for itself. The counter norm to this is particularism. We evaluate the research by the reputation, maybe of the researcher or the lab, what's come before. Disinterestedness, that I'm doing this work because I'm motivated by knowledge and the discovery. And then with self-centeredness, it's treating science as a competition. I'm doing this because I want to get ahead. What I'm doing is all about beating the other person to the punch. The positive norm, organized skepticism. I'm going to consider all new evidence, even against my own prior work. Just because I've developed some theory thus far in my career doesn't mean that if I found evidence contrary to it, that I wouldn't publish it and report it and be open about that process. Organized dogmatism, it's saying, no, actually, my career and my tenure matters more at this moment, my advancement. And so when we're thinking about norms and counter norms, quality versus quantity, this has a lot to do with what we believe, but then it also has significance for how we behave. So what Anderson et al. Did is they interviewed over 3,300 researchers. And they asked them, or they surveyed over 3,300 researchers, early career and mid-career. Early career is, recent postdoctorates, and mid-career having just achieved their first R01. And they asked them what they believe in, if they endorsed either the norm or the counter norm. And this is what they found. So if we look at the long gray bar, that is the survey's responses, their belief in the norm. The gray striped, the smaller gray striped band is their kind of 50-50. It was all, the norms and the counter norms were put on different scales, and so if they had kind of a mixed belief, then it was the gray stripe bar. And the black bars, you could see very few people actually endorsed the counter norms and believed in the counter norms for themselves. Okay, so that's what they believed. Now, if you ask them then what they did, this is how the researchers reported them. So you can see there's a little bit of a shift. They say, well, I believe this. This is the scientific ideal that I'm working toward or that I would like to see in the world, but reality has intruded, and this is where I am. This is how daily practice actually looks for me. Okay, well, that's how you believe, and that's what you do, but what about everyone else? What are they up to? And that's where things get kind of interesting. Because others, your perceptions about what other people do, the researchers reported that others were big liars, cheats, and thieves, right? And what we're seeing here is that when we believe that other people are engaging in these counter norms, and we have all these incentives to publish, to self-promote, to get tenure, to win grants and advance professionally, and we believe that everyone else is engaging in these counter norms, that starts changing our own behaviors as well. And so this is something that's significant. There are a lot of barriers to people engaging in the scientific ideals. You know, there's the perceived norms, of course. There's motivated reasoning. There's, that can impact my understandings of how the results work. Like, I think that things are going to turn out better, or people who do this type of work generally find this, and therefore I'm going to do this because I'm going to succeed better if I engage in these behaviors. There's also minimal accountability. Most of the time, most of that research life cycle is only reflected in the published report. You're not seeing what's happening on all of the other steps in the process, and so there's not a lot of accountability toward documenting how your process is or how the sausage was made, if you will. There's a food example. Concrete rewards beat abstract principles, and then also just the simple fact that I am busy. It's hard to clean up my data. It's hard to get things out there and ready in such a way, especially when there are norms that are working against this in my field. So we're going to talk a little bit now about open data. So what is open data? Well, at a general, most basic definition, we could say that open data is data that could be freely used or reused, but we shouldn't think about a definition of open data in terms of absolute terms, because it varies by discipline and it varies by context. And this is because of the potential privacy issues that exist. So why? Why should we have open data? First, it can improve reproducibility and replicability. We have probably all heard of the reproducibility crisis in science. And so when we're open with our data, then we have a better chance of being able to reproduce our results or have others reproduce or extend our results. Increased efficiency. We waste a lot of resources reinventing the wheel when we don't have all of the data that's available to us. It increases the reuse and extension of knowledge. Public data, existing public data, can be combined with the private data that you're collecting. And open data, it can influence scientists, entrepreneurs, policymakers, citizens, consumers. When data sets are open, there's just a lot of very positive benefits overall. But that does not mean that it's easy. There are certain challenges. So how do we make our data accessible, understandable, reusable in a format that's accessible to others? Maybe your data exists in a format that you need a certain proprietary software in order to engage with. Which repository should I choose? This brings up issues of data storage. Who's going to maintain that repository? Who owns the data? Do I have a copyright on the raw data if I collect it, if I make it open? If I reuse someone else's data, do I have to give them authorship on my paper that I developed if they're the ones who collected the data? How should we address privacy issues with large data sets or even with small data sets? These are all challenges that we face that we need to be engaging with as policymakers. And as people who are engaged in a change in the scientific culture at this time. And so the next thing I would like to talk about is transparency. And so when we talk about transparency, I'm going a little bit beyond open data, because we're talking about open data as just kind of the nuts and bolts and the numbers and the figures. Transparency is making clear the process. How did I collect the data? How did I analyze the data? How did I develop my research questions? This is all what's entailed in the questions of transparency. And so if we seek to facilitate reproducibility, replicability, extension, reuse, then we need to go beyond just a description of outcomes that we currently have in the published reports and get into better descriptions of the processes, or better yet, sharing the actual process. And so our vision is to get beyond these questions of, say, open access or open data, open materials, open data cleaning scripts, open, you choose whichever step in the process is going to come next. And then instead make it about an open workflow so that our process of creating science, our process of doing science becomes clear not only to other researchers, but to the general public as well. Some of the conversations I had last night with guests in this room talked about how there's often a public misperception about what occurs behind the scenes, especially in industry, but looking at food science. And so there's a sense of, oh, well, people eat this much sugar. Well, that might be different than how much sugar they actually eat. Or there's a perception that artificial sweeteners are bad, or genetically modified foods are bad, while the research may bear out different things. So if we can make our process more open, we can actually increase the trust and the integrity in the process. Open workflow, again, increases transparency, accountability, reproducibility. It facilitates meta-science, so studies on the type of work that we do. It fosters collaboration, inclusivity, innovation, and then it also protects lock-in. So I mentioned that sometimes our data might be housed in proprietary systems. So like my boss gives an example of Apple. We are a very, very Apple-centric office, and I was a PC girl before I joined the Center for Open Science. I have had to change my ways in all of my systems to accommodate the Mac world. It's just one kind of silly example, but it does, depending on the software you use, it can actually close, it can create a barrier for reuse for many others. Okay, so where do we go from here? Challenges for the future. I thought about talking about challenges for the future, but I realized it seemed a little bit negative. And so instead I'm going to talk about opportunities. And I'm going to talk specifically about the work that we do at the Center for Open Science and highlight some of our initiatives to facilitate a culture change in science. So our work at the Center for Open Science is conducted primarily by 3 teams. There's the infrastructure team, the meta-science team, and the community team. The infrastructure, they're the developers who build our technology. The meta-science team, of course, conducts research about research. And the community team, we do outreach with researchers, librarians, journal editors, institutions to try and, again, everything is about bringing about those scientific ideals and improving the transparency, integrity, and reproducibility of scholarly work. All right, so I'm going to start with the meta-science team briefly. They did the reproducibility project in psychology. This was a large crowdsourced empirical effort to estimate the reproducibility of a sample of psychology research studies. They attempted to replicate 100 studies, and they found about 30% reproducibility of these seminal works in psychology. Now I've lost my mouse. Okay. The next project that we have currently ongoing is the reproducibility in conserved biology. We've just started publishing on our first replications in eLife, and then ongoing right now is the reproducibility project in social sciences. Data collection is still happening, but it should be closing soon. The community team. I'm going to talk very quickly about 3 different initiatives that we have in place to help incentivize openness presently, and some of them may apply for you. The first, when we're trying to get about a culture change, I've mentioned the journals before. The journals are absolutely significant. And so one of the things that we're trying to do is encourage the journals to incentivize openness as part of their process. And so in 2014, a meeting was convened at the Center for Open Science, and it involved journal editors, researchers, kind of leaders within the field, funders, a variety of stakeholders to develop a series of guidelines. And so they came up with 8 policy statements that are about increasing the transparency and reproducibility of published research. And they're agnostic to discipline, there's a low barrier to entry, and they're modular. And so the idea is that you might be at one level in a particular guideline, but at another, in a different standard. So there are the three tiers. The level 1 tier is that the authors must disclose if they engage in some action. Level 2 is the authors must share, although there are exceptions permitted. And then level 3 is that the journal or the third party will verify that the standard has taken place. So right now we have about 3,000 journals who are top signatories and over 60 organizations. I went through our top signatories of journals, and these are some that might apply to you. But if you go to our website, you can find more about the specific journals. To become a top signatory, the journals express their support for the principles of openness, transparency, and reproducibility. They indicate that they are expressing interest in the guidelines, and they commit to conducting a review within a year of the standards and the levels of adoption that they're going to assume within their journal or their organization. So those are the top guidelines. Tied to this, also working with journals, open practice badges. The first journal to institute open practice badges was Psychological Science. And what the badges are, it seems a little silly, it seems a little corny that you're having a badge that you're putting on your published materials, and it can indicate whether you have open data or open materials or that you pre-registered. But it actually had a significant impact on behavior. And so we conducted a study of what happened when Psychological Science implemented the open badges in 2014. And so that's the kind of the red dashed line down the center there. And what we saw is that they went from about 3% sharing of their data to about 40%. There was a dramatic shift, and then in the comparison journals, there wasn't the same shift. So badges are a very low-cost, easy way of signaling that as an author, it's important to you to be open with your data, but also for the journal to signify that it's open for them, that it's important for them. And as a side benefit, there is some evidence that authors that studies with open data are cited more frequently than those without. All right, so which journals issue badges? Presently, it's about 15 journals currently issue badges, more to come. All right, the final one I want to talk about briefly is registered reports. And the way a registered report works, instead of the peer review happening only after the report is written and the study is complete, that there's 2 stages of peer review. So the first stage of peer review is that journals would take your introduction, your methods, and your analysis strategy, and they would evaluate your study design and make publication decisions based on your study design at the time in the process when it could be most useful for you. And they could accept in principle, they could invite you to revise and resubmit, or they could reject. But if they accept in principle, what happens is when you go out and conduct your study, you have a public, and assuming that your study matches what you set out to do in your accepted methods and analysis plan, then you've got a publication. And this is a really important step in countering publication bias, because what we know is that there's a very serious publication bias in the sciences toward studies with positive results. In some of the physical sciences, at the best case scenario, it starts at about 60% of the studies published in academic journals show positive results. In psychology and psychiatry, it's over 90% of the studies have positive results. And when you're talking about how science works, I think you all know that that's not how science works, that your hypothesis is not confirmed 70, 80, 90% of the time. And so what this means is that we have a very serious file drawer effect, and we don't have a very clear sense of that research landscape when we don't know what's going on. Okay, and I think I am just about out of time, so I'm just going to, oh, I'm good? Okay. And by the way, right now I think there are 67 journals that accept registered reports, and so this is something that we want to encourage further. The infrastructure team. So these are the developers. At the Center for Open Science, we have about 70 full-time staff, and about 2/3 of them are developers. And they develop tools like the Open Science Framework. And this is a free web application. It's a free open source scientific commons. As I said, everything that we do at the Center for Open Science is free and open source and transparent. So this is what it looks like. It's a site for collaboration, documentation, archiving. So within the Open Science Framework, the OSF, it's easy to curate a project, to add contributors, to share. There's an activity log so that you can see what has happened at different steps in the process. Any type of file can be uploaded to the OSF, and most file types can be rendered. There's also automatic file versioning, which is, especially when you're working on collaborative work, I don't know about you, but I, in my collaborative writing projects, have hit the wall with final draft, final draft, really final draft for publication, and it can be a little bit headachy. There's automatic versioning within the OSF, and so it will show who made the change, what changes they made. You can access and download the different versions of any particular file that you have in place. As far as citations, it generates automatic citations so that if you were to, say, upload a data set on the OSF, you could set up the citation so that anyone could very easily cite your work of your data set. And then the URL for your project, every component, every file has a unique GUID, globally unique identifier or URL that you can use, that you can point to in your web pages, in your CV, in your journal articles, to make it easy for people to find your work. And then along those lines, also easy to see the impact of your work. So the OSF for public projects, it displays analytics, so you can see the number of unique visitors that you have coming to your pages, which pages they're visiting, the top refers to your particular project. There's information about the number of downloads of any individual file, and also any time that your project has been forked or templated. And it's one thing to say, oh, well, I already have all of these systems that I work with and that I like. The OSF actually integrates with many of the services, the cloud-based services that researchers already use, like GitHub, Drive, Dropbox, Amazon S3, and then these are the ones that are coming. So these are the ones that are in development. So to go back, these are the ones that are available currently as integrations within the project, and then these are the ones that are in the pipeline. Okay. The next thing I want to talk about briefly, preprints. We do a lot of work to encourage preprints, which could be defined as a complete written description of a body of scientific work that has yet to be published in a journal. So this could be a research article, it could be an editorial, a review, a comment. It could be an article that was, a manuscript that was rejected for publication. It could be a manuscript that just has not been published yet. The Center for Open Science, we've developed a preprint server to encourage people to share their preprints and share these different research outputs. And so we have this pre-built preprint server that groups can use for their own services with their own branding. So for example, SocArchive, AgArchive, SciArchive, and for some reason my thing is trying to go ahead of me. These are all preprint servers that we've built, and so I'm not sure if this would apply for you, but if you were interested in the future in developing a nutrition science preprint server, it's something that already exists, that we have the template available and it's open source for you. And all of these materials are actually then cataloged in the share service. And so if you go to share.osf.io, it's a kind of like an open source Google Scholar. And why is this going? Okay. It's an open source Google Scholar, if you were. And so what it does is it catalogs the research outputs, but institutions themselves can decide what constitutes a research output. So last night I just did a search for nutrition, just as a keyword. And it brought up over 140,000 unique events from 126 sources. There were about 125,000 publications, 1,600 data sets, 22 presentations, and 11 posters. And so this is just from one word, one search that I did last night. So when we're talking about openness and transparency, people find a lot of the work that you do interesting, even the work that you may not think is very interesting, like a survey instrument. And so openness can take a lot of forms, and you can share them in a variety of ways. And so the share server is one way to do this. All right, so key takeaways. The first takeaway is that we should be aligning our scientific values, open sharing, the value of evidence, with actual scientific rewards. So getting published, funded, and hired. And so it's going to necessitate a shift in our current scholarly culture. And then the next is that we need to make tools that make researchers' lives easier while making open science as easy as pressing a button. Because if you ask people to engage in a burdensome process to make their data more open or transparent, then it becomes much more challenging. But if you make it simple and you make it normative, then it's going to be a lot more likely to happen. And so that's what we've endeavored to do. Okay, so with that, that brings me to my close. If you have any questions or comments.
Yeah, well, thank you. Again, we probably have time for one or two quick questions before we break for lunch, if there's any.
Really interesting, but just your thoughts in terms of concern. I really like the idea of data being open to everyone.
Mm-hmm.
The one thing about science is it requires a little bit of, there's a reason why there are journal editors.
Mm-hmm.
Hopefully there's a reason why there are journal editors. So with this idea of these preprints essentially coming out, is there concern about how the media would kind of have access to those and what they would do with them? I just really concerned that people like to take these sound bites, and if it's something that's published and hasn't even been peer reviewed, I can just imagine the chaos that may ensue if there was a relatively controversial paper that was reviewed.
Absolutely. That's a really great question, and I think in this era of fake news, I think very important. And I would actually use the news as an analogy to this. So right now, with the internet, we have access to thousands, millions of different news sources, whether it's newspapers or journals, magazines, blogs. There's or just listservs where people can get information. And there's an important job that happens in filtering those sources of information. And I used to teach undergraduates, and I had spent a lot of time teaching them what was a valid source and what wasn't for citation. And I think in the same way we need to do that with preprints and other scholarly outputs. And it's not that we want to eliminate journals. I think journals have a very important place in the scholarly ecosystem, but we want to change their role. So instead of being the kind of the ultimate gatekeeper who decides whether someone gets published and therefore is likely to attain tenure or a grant, that instead that they are measures of quality. I'm trying to think about how to speak more clearly. The peer review process is absolutely key, and we could envision a world in which people are given prestige based on the strength of their peer reviews. And so if you were to say have open peer review, that by making the process more transparent, more open, that we're encouraging people to put their reputations on the line by being the best that they can be. And so if you're putting your stuff out there and that it's open and people are looking at it and they're saying, actually, I'm finding that you skipped a series of key steps here, why don't you go back and reconsider it? And then you go and you say, absolutely, I'm so glad you highlighted that, I'm addressing it. I think we have an important way of dealing with quality control that is sometimes lacking, especially when we look at like the few retractions that happen in journals and so forth, or that a retraction might only be published years down the line after a study has already entered the general public and been cited repeatedly. Most often, people aren't going back and citing the retraction. You know, I'm sorry, I'm not sure if I addressed that entirely.
All right. Thank you.
Right.